Hello students, Professor Gray here. We need to talk a little bit about how we do measurements with the metric side of the ruler, with the imperial side of the ruler, and what we mean by level of precision and or uncertainty of measurement. Now, if we take a look at this picture here, you will see a ruler that I grabbed from my junk drawer and a little teal object. And what you'll also notice is that I have it being measured with the metric side of the ruler. And how you'll figure that out is because right here we have millimeters. And I need to point out that the little dashes right here, up here, those are your millimeters. The big 0, 1, 2, those are centimeters. So even though the ruler says millimeters there, most of the time what we're looking at, the 0, 1, 2, 3, is centimeters. So I know that's kind of weird, but that's how it goes. Okay, so how would we measure this? Well, the first part of it is usually pretty simple for most of us. What we do is we say, okay, that looks like it's definitely gonna be 7 point something. And so we know that it's definitely not 6 centimeters and it's definitely not 8 centimeters. So we're really sure that this teal object is at least 7 centimeters. So I'll go ahead and label this as our certain digit there, okay? So we go ahead and we put point something because we can keep going. And for most of us, if we look at it with our naked eyeballs or with our glasses, we can see that it is 7.7. Okay, so if you need a close-up, there we go. So this right here, that would be 7.5, and we are right here at 7.7. Okay, so we can also say that 0.7 right there, that 7/10 is certain. We're sure about it. We're sure that it's not 7.6 and it's not 7.8. But the next step is something that a lot of students don't like to do. A lot of students don't like to make an estimate or a guess and go another digit. They just like to stop right here. That's pretty normal. But in science, we need to go another digit. So if you take a look at this, and let me go ahead and erase this right here. There we go. What we'll notice is that it goes slightly over 7.7. And if I go ahead and expand that a little bit, you can see that a little bit better. But if we're in the lab, you probably don't have that feature in your eyeballs. So we're going to have to go and make a guess right here. Now, some people might say, oh, well, that looks exactly on 7.70 to me. So some people will guess that. And some people will look at it and say, no, that looks like 7.71 to me. And some other people will look at it and say, nope, that looks like 7.72. Well, the thing is, all three people are correct because this number right here is uncertain. Or we're not sure about it, or it's our guess, or it's our estimate. So as long as those first two numbers match with all three of the people making the measurement here, we're good because those are the certain numbers, and the last one is uncertain, so there's wiggle room there. Now, when we're talking about level of precision or uncertainty in measurement, we're saying right here is our uncertain digit. Now, how certain of that are you? And so how we indicate that is with the plus or minus symbol, and then we write something here. Now, I want to point out that the number that you put over here, where it goes plus and minus something, is always going to end in the same column that your estimated digit went. So what we're going to do is we're going to say, okay, we've got 0.0 and then something right there. Because that's where we have our wiggle room. That's where we have our estimate, and we want to say how sure we are about that. Now, how we do this is you go ahead and you look at the space between 7 and 8. Okay, so we've got 7.7 and 7.8 right there. And notice in between those lines is a really tiny space. And it's tinier if we go ahead and zoom out like that and look at it how we would really be looking at it. Now, what we do is we say, okay, with our eyeballs, can we see where 0.01, 0.02, 0.03, 0.04 are? If you can see all that with your eyeballs, you would go ahead and put, okay, I think this measurement is 7.71 plus or minus 0.01. So you're saying, I'm really sure of this, and it could be 7.70 or it could be 7.72, but I'm pretty sure it's 7.71. Now, most of us would say, ooh, that space in between there is a little bit small, and I don't think I can make out where 0.01, 0.02, 0.03 are. So I'm just going to say my eyeballs can pretty much tell if it's in between 7.7 and 7.8. So I'm going to say, I'm not super sure, so we'll just call it half of that. So halfway between those two numbers, since that the distance between here and here is 0.1, is 0.05. Okay, so if you want to be on the safe side, you're just gonna go ahead and take your smallest divisions, which for centimeters are 0.1, 0.2, 0.3, 0.4, on and on like that, and cut it in half. Okay, so again, the distance between here and here is 0.1, and half of that would be 0.05. Okay, so if you're saying that space is so small, I can't make out 10 different little divisions with my eyes. I can just make out whether it's in between 7.7 and 7.8. I'm going to call it halfway between, 0.05. And I'm sorry if you can hear my child yelling in the background. I did tell them I'm doing a video and please be quiet, but you know how that goes. Okay, so where does this information go? Well, this chart right down here, which you guys have for your lab, you would write 7.71 here. And again, if your lab partner measures it and says, no, I think it's 7.72, he or she is correct because that last digit is uncertain. It's our estimate. It's where we have wiggle room. And the plus or minus on the bottom where we have level of precision or uncertainty in our measurement, we would probably put 0.05. And again, make sure that the level of precision, the final digit, goes to the same column that your measurement went to. Okie dokie smokies. All right, so let's back up to millimeters. So let me do a little bit of erasing here. Okay, and for millimeters, we have 10 millimeters for every 1 centimeter. So if you went ahead and you did the math on that, you would know that you would be expecting 77.1 millimeters. But we're not supposed to do that. We're supposed to actually measure it. So actually measure this, my friends. So if we look at this, we can see, okay, we've got 10, 20, 30, 40, 50, 60, 70 millimeters. And remember the small little dashes, those are our millimeters. And then we're at 70 now. So this would be 70 millimeters. And this right here would be 71. And this right here would be 77. Okay, so we should be on the same page now. So let me back up a little bit, and we're at 77 right now. And what you would do is go, okay, with my eyeballs, I can see that it is definitely 77 millimeters, and it's not 76 millimeters, and it's not 78. So 76 would be, 76 would be right here, and 78 would be right here. It's definitely not one of those two. It's definitely on 77, okay? So again, these are certain digits. And then in between there, what we have in between here and here, we have to make a guess, okay? So remember, you have to guess one more, okay? So you do point and then do your best guess. And maybe you say, okay, that's 77.1, but your lab partner says, no, that's 77.2. And you guys, just for consistency, agree on 77.1. So what you would do is you'd go down here and you'd go, okay, that makes sense, 77.1, and then you'd go, oh, what is this level of precision thing down here again? I know she explained that to me, but it didn't really make sense the first time. It was weird like significant digits were. Yes, it is weird like significant digits. What I want you guys to notice is with millimeters, our guess is in the tenths column. So where should your level of precision for your measurements or your uncertainty go to down here? It should go to this column right here, because those should correspond. Because you're saying I've got uncertainty here, okay? Well, how much uncertainty is kind of what we're talking about. Now, if we go back here, what we're going to say is, okay, so plus or minus a certain amount. And we know that we have to go to this column right here. Now, between 77.1, between 77 and 78, right here, this distance right here, can you cut that up into 10 different graduations so that you can for sure see 77.1, 77.2, 77.3, and if you can, you would go ahead and put 0.1, but most of us can't. So we would just put 0.5. So we have 77.1 plus or minus 0.5.